Today I'm showing off my research that I've completed for this quarter. This is my last quarter for the research, but it's definitely a project that I want to continue with. The idea of the project is that I've created a game engine during the first quarter, and now I'm binding it into LUA. And I just wanted to talk a little bit about the challenges that I came across to bind everything into LUA in such a way that it's usable, it's maintainable, and actually makes sense. Because the whole idea behind binding a game engine or a framework into a scripting language is to make your job easier. And to make your job easier, it means that you have to do less code, that the iteration cycle between testing is much quicker, and that you can see usually results in real time. So the power of LUA is that you can actually, once the script gets reloaded in real time, you'll see the actual effects without actually having to restart the game. And there's a whole science behind why that's important, but that's not part of the research. So I kind of want to talk about a little bit about the actual build process of this project, because it's fairly complicated. And the reason it's complicated is because it got split into all these different parts, such as the game engine, and then the actual LUA bindings, the C++ LUA bindings, and then the actual LUA engine. So what happens is that I have to first build the actual game engine, and then I have to build the LUA bindings before I can start actually doing anything in LUA. And how this happens is that it took a little while to figure it all out, especially because if I make one small change in the engine, it means I have to rerun and recompile everything. So what I ended up with is basically Sublime runs a series of batch scripts which first compile the engine, then take all the libs and headers from the engine and copies them into the actual LUA bindings. And so from there, basically the LUA bindings project solution has the latest headers and lib files so that it can compile into them. And then after that, the actual game gets assembled, so it has to copy around like the DLLs that are like for the different libraries, such as Erklang. And the actual resources for like game resources, so the images or the textures, the sounds, have to be actually all compiled into a single folder. And so I can show you a little bit in so I use Sublime for the LUA side because Visual Studio does not natively support LUA, and there's very good tools out there like Sublime that provide like syntax highlighting and all that stuff. And so here I can see the game, and this is basically the result of the compilation batch scripts. It basically takes all the assets and copies them into game after it builds out all the engines. So that was the challenge of getting everything mainstreamed so I can iterate on the actual game development side pretty quickly. The other side is I quickly discovered that a lot of things had to be integrated into the actual LUA bindings side that may not or completely fit into the engine. For instance, I had to wrap things into a LUA object, which manages the LUA state and things like that, and then relays like changes to position and things like that back into the engine. And so the other thing that I had to do was object pooling, because ultimately like special effects and things like that have to be pooled, or else you end up allocating and deleting things that are only on the screen for about like a second and a half, and that doesn't make any sense. So you'll see in a second how that object pooling mechanism is used. And then also it took a while to figure out like what the actual stages, like the life cycle of a script is. So the life cycle of a script in this case is when the script runs, it first runs through the outer scope. So you can see, like for instance in main, I have things that are in the outer scope, so it does that first. and then it calls initialize. And then after that it loops through update until it has to destroy the object, upon which it calls on destroy. And so the objects get a last chance to do something before they're completely deleted out of the scene. And the reason for that is, for instance, if I was to delete something and I wanted to play a sound every time that it got deleted, it's very useful to have something like on delete. And part of the mess was to decouple things like the world step and the update and the initialize and delete, because something might get deleted while it's still in world step, and that created certain issues, especially when you're colliding. You're in the world step, on delete gets called, and you have to figure out how to decouple all of that so that things don't intertwine and don't cause issues. And so what the engine does is it right now can pool objects, it can play sounds, it can render, it can do depth for the sprites, it has full integration with Box 2D, and so all of that gets transferred into the LUA side. So I'm going to actually show you what the game looks like so that you can get an idea of what it all is coming to. And so what happens is I hit Control-Shift-B, and so you can see all the compilation running and the copying and things like that, and it's actually pretty quick as far as, you know, getting everything up and running. And so you'll notice that there's a bunch of stars that actually have different depths to them to create this kind of parallax effect. And all of the stars are pooled. So once the star dies, it runs off the screen, it actually gets repooled and then reappears on the other side when, you know, a request for a star comes in. And so I'm going to start shooting at these alien ships to see, like, the alien ships are also pooled in the same way. Because once they're deleted, it starts to spawn a new one as a replacement for it. You'll notice that there's also sound, so every time I shoot, it basically just plays a sound, and every time something gets destroyed, it plays a sound as well. The game is hooked up to a joystick, but you can also use a keyboard. That's all part of the bindings. And so this is what I have so far as like testing out all the bindings and things like that. And I'm gonna start adding once summer comes like in full swing. My plan is to start adding text and things like that to like give it a more like actual game feel, to where you can display scores and things like that. And so the other thing I really quickly wanted to talk about is how things are managed, like in the engine. Everything has a hash, so everything is managed through maps, or hash maps. And the reason for it is that what happens every time I create an object, it gives it an ID number. And I can use that ID number to look it up very, very quickly, without having to deal with things like pointers and stuff like that are completely native to C++. And the reason that's important is because if I wanted to bind my engine into something like C# or like Python, and all of them have a different scheme for managing variables and things like that when they cross between C++. And so this allows me to just work with strings and integers and just functions to just kind of send commands back and forth from the engine and to read stuff out of the engine without having to deal with objects and pointers and things like that. So, so yeah, I have a write-up that explains things in a lot more detail, but I thought I would show what I have so far. And it definitely has a lot of potential for a lot of exciting things to add in. And the nice thing is really simple to add stuff in, which I'm pretty proud of. So thank you very much for watching, and have a good day.